is number 12 and number 26. Both of them deal with finding the domain, and 12 also deals with finding the range. So it says to find the domain and range algebraically. Honestly, for this problem, for number 12, I don't see how you can find it algebraically. You got to find it more intuitively, because domain, if we remember, domain is all x values that work. And the only time an x value, I'm sure there's a bunch of other times, but two of the main ones when an x value wouldn't work is if it's in the denominator. So if you had like x in the denominator, you couldn't have x equal to 0. If you had, if you had x minus 1 in the denominator, you couldn't have x equal to 1. Because those values make math fall apart when you have a 0 in the denominator. Okay, the other times where you have a problem is when you have square root. Because we can't have the square root of, say, let's say x is negative 7. You can't have the square root of a negative number. Right? There's no two numbers that multiply to get to 7. You know, even if you have a number like 9, which is, if I take the square root of that, that's 3. The square root of negative 9, what is that? 3 and negative 3? Doesn't make sense. Okay? Because both numbers need to be the same. So, this one, we're not going to have an issue with the domain. Because any x value I put in here, I'm going to square. So if I square a negative number, it just becomes a positive number. And if I put a positive number in, it's just a positive number. So this is going to be 4 minus a big number possibly, but it's still going to be a value we can get. Okay? So for the domain, we have no problem with the domain. Any number between negative infinity and positive infinity work. So for the domain, it's negative infinity to positive infinity. Now for the range, that changes a little bit. Okay? The range is what numbers can we expect? What numbers are possible? So if I were to kind of look at this problem, okay, I have 4 minus a number. And we can see how, well, let's maybe what sometimes you need to do is just pick some values for x and see what you get for y. So I'm going to pick some easy ones. Okay, if I put a negative 2 in there, I get 0. If I put negative 1, I get 3. If I put 0, 4 minus 0 is 4. 4 minus 1 is 3. 4 minus 2 would be 0 again. So do you see what's happening here? What are the numbers going to look like if I go this way with x? What are we going to get on the y side? You see how we'll just get negative numbers up here? Okay, what about down here if I continue with x? You see how we'll just get negative numbers? Is it easy to see? Yes or no? I don't know. You can tell me tomorrow. Is it easy to see that this is the biggest y value we'll get? So then for my range, what numbers can I expect? Well, I can expect all the numbers from negative infinity, but I'm not going to expect anything over 4. That's the biggest y value I can get, and that'll be when x is 0. Okay, what if x, now we can look at what if it's in between here somewhere. What if it's between negative 1 and 0? I hope you can see that no matter what numbers, 0.5, if I put a 0.5 in here, I'm still not going to get a number as big as 4. So this is number 12. Hopefully that helped. How about the next one I had was 26. Okay, so 26 a little bit different. All we have to do is find the domain. So in class, we had a rule, if we have a square root, plus 6. So here's the function. So the only thing we need to know about the square root is it can't be a negative number, right? We can't have a negative x. It's got to be 0 or bigger, okay? 0 or bigger than 0. Okay, so here's how you solve these. Set this whole thing, and this is one we can solve algebraically. Set this greater than or equal to 0, because this needs to be 0 or at least a positive number. So now we can solve this. This one requires a couple more steps. If I factor this, I get x minus 3, x minus 2, greater than or equal to 0. So when is this times this greater than or equal to 0? So here's how to solve this. I make a number line, and I put these two numbers, the two zeros. So x equals 3, and x equals 2. I put a 3 here, and a 2 here, okay? And now I figure out, I pick a number smaller than 2. Let's go with 0. That's an easy one. So all the numbers in this range, 0 is a good representative of it. If I put 0 into the function, what do I get? So 0 for x. So that's 0 plus, or minus 0, excuse me, plus 6. Is that greater than or equal to 0? Yes. Okay, how about in between here, 2.5? Okay, if I put that in, I can use my calculator. Go ahead and try it. 2.5 squared minus 5 times 2.5 plus 6. That's a negative number. So when I put 2.5 in, I get negative 0.25. That's a negative number. So this area between here and here, we're not greater than or equal to 0. Because we got a negative number. If I pick any number between here and here, and that's how this works, any number between 2 and 3 will give us a negative number. So the function is not greater than or equal to 0 between 2 and 3. Let's check over here. Let's pick a number that's over here. How about 3.5? 3.5 is greater than 3. So it's in this area. So if I put 3.5 in, squared minus 5 times 3.5 plus 6, I get 0.75, which is greater than 0. Okay? So what this is telling me is the graph looks something like this. Okay? In fact, specifically like this. Okay, it's going to cross the y-axis at 2 and 3. Okay, in the middle here, 2.5, that's going to be the lowest it can possibly go. And I checked that number, that was negative 0.25. Okay, so this is going to help us with our domain. Where is this function greater than or equal to 0? Well, between negative infinity and 2, including 2, or between 3 and beyond, up to infinity. So this would be the domain. Okay, the range, well, we checked this number that's right in the middle, and thankfully for symmetry, that's the lowest we'll go, and that was negative 0.25. So that's as low as we'll go, negative 1/4. And we can equal that, and we're going to go off to infinity. That's our range. So this would be range, this would be domain. These are all the x values that make this function work greater than 0. And I think we also got to take the square root of that negative 1/4. So 0. 0 is the lowest this goes because we can't have a negative number. I'm going to have to check on that.